Humans spend hours preening themselves in mirrors. Reflections in mirrors are amazing things that tell us a great deal about how we see ourselves. But what do reflections tell us about the mirrors themselves? What exactly is a mirror and how does it work? In this video, we will explore the reflection of light and how it relates to mirror.
Before we jump into the explanation of how mirrors work, try to think about your daily experience with mirror and see if you can come up with the answer to the following question. Suppose you want the other you, that is, your reflection in the mirror, to be 20 feet away from you. Where should you place the mirror to make that happen? A. 5 feet from you. B. 10 feet from you. C. 20 feet from you. And D. 40 feet from you. Correct, you got it. The mirror should be placed 10 feet from you, which means your image is also 10 feet behind the mirror. Let me show you why this is the case. That's not correct. You're close in that you know you and your image are on the different sides of the mirror plane, but you missed the relationship among the positions of you, your image, and the mirror. Actually, the mirror should be placed 10 feet from you, which means your image is also 10 feet behind the mirror. Let me show you why this is the case. That's not correct. You may think that your image is exactly where the mirror plane is, but actually, the mirror plays a trick with you. Actually, the mirror should be placed 10 feet from you, which means your image is also 10 feet behind the mirror. Let me show you why this is the case. That's not correct. You might think that there shouldn't be anything behind the mirror, but actually there is. In fact, the mirror should be placed 10 feet from you, which means your image is also 10 feet behind the mirror. Do you understand why? Let me show you the reason.
First, let's introduce the concept of light reflection. In fact, we can see ourselves in the mirror due to the multiple reflection of light rays. The light rays from the source are first incident on our body. They bounce off from our body and fall on the surface of the mirror, and then get reflected from there. This reflected light then reaches our eyes and we see our image. This tells us that a light ray can get reflected multiple times. But why the image we see in the mirror appears to be formed in the position somewhere behind the mirror? Now let's learn a new concept, virtual image, the image we see in the mirror. In order to explain what a virtual image is, let's firstly simplify this image. Let's represent this boy with an arrow pointing up. And here is our plane mirror. You can assume the top of the arrow to be the top of the head of a boy. Now, where is the image of the boy formed? When we see the image in the mirror, it seems to us that the image is formed somewhere behind the mirror, but actually there is nothing behind. For instance, consider a few light rays emerging from the top of the arrow. All these rays are incident on the mirror and get reflected back. You see that all the reflected rays are moving away from each other. That is, they are diverging. Let us extend these reflected rays backwards and see what happens. We see that they meet at a point behind the mirror. To us, this is where the top of the image appears to be. When we look at this point, it appears to us that all the light rays are diverging from this point. But in reality, there are no light rays behind the mirror. This being a smooth and shiny surface reflects most of the light back and almost no light reaches behind. But yet we have the perception that the light rays are coming from the point behind. So we just consider the top of the arrow here. We can do something similar for every point of the object to get the complete image. This is how virtual image is formed and how we see the image in the mirror. According to the law of light reflection, the angle of incidence equals the angle of reflection. That is, angle 1 equals angle 2. Since both angles are measured with respect to the normal to the mirror, and that the normal is perpendicular to the surface, we can see that the two lines are parallel. Because corresponding angles and alternate interior angles in parallel lines are congruent, we can see that the four angles are the same. Since the triangle A and triangle B share the same edge, we know that the two triangles are congruent. This is why the distance from the mirror to the real image equals the distance from the mirror to the virtual image. That is the end. Hope you can learn something. Thanks for watching.